Hey everyone, welcome back to Tech Insights for Visionaries. I'm Maddie.
And I'm Sean.
This podcast is produced by a team of software engineers from MobiDev, an international software engineering company. MobiDev invests into technology research and has years of experience building AI-powered solutions, implementing machine learning, augmented reality, and IoT.
This is an exciting topic that I've been looking forward to. Today, we'll be talking about AI virtual assistants.
Oh, like Google Assistant and Amazon Alexa?
Yep, AI virtual assistants are a familiar part of our daily lives. But today, we're going to talk about what lies under the hood of these digital assistants. More importantly, we'll talk about how businesses can leverage them to stay relevant and competitive in the market. So, let's clarify what intelligent virtual assistants, or IVAs, are. These are AI-powered agents capable of generating personalized responses, pulling from contexts such as customer metadata, prior conversations, knowledge bases, geolocation, and other modular databases and plugins. The intelligent virtual assistant market, experiencing rapid growth in the 2020s, is forecasted to reach $6.27 billion by 2026, according to Mordor Intelligence.
Wow, that's a big industry.
AI assistance is in many ways similar to traditional chatbots powered by natural language processing. However, intelligent virtual assistants integrate next-generation analytics, machine learning, AR and VR, and data science. While conventional chatbots can generate responses to inquiries based on Markov chains and other similar processes, their static responses pale in comparison to the dynamic insights generated by intelligent virtual assistants. IVAs like Google Assistant, Alexa, and Siri help customers easily execute commands with voice prompts, automating tasks such as setting alarms on smartphones, verbally reading out emails with text-to-speech technology, playing and searching for music, and sending text messages. The same technology has been included in automobiles by car manufacturers. We can see this technology in all sorts of industries, including healthcare, telecommunications, travel and hospitality, retail, and BFSI sectors. Consumer products include smart speakers, smartphones, cars, commercial vehicles, home computers, home automation, appliances, and many more.
So why are industries using AI and for what purpose?
The main advantage of using artificial intelligence to create such solutions is that AI can efficiently and quickly process huge amounts of data, find insights, and provide smart recommendations. Powered by voice and speech recognition, AI assistants make it much easier to perform many daily tasks, such as adding events to your calendar, setting reminders, or tracking monthly expenses. According to Statista, there will be over 8 billion digital voice assistants in use worldwide by 2024, roughly equal to the world's population.
Oh, I see. What about key benefits of building virtual assistants for business?
The key benefits are improved customer support, the ease of key data collection, and a personalized user experience. Virtual assistants can improve customer support while cutting down on the number of calls and service requests to human agents. With AI assistants, you can automate the business flow of interacting with customers. This will allow your employees to focus on more complex tasks and not waste time on requests that can be processed in an automated way. Data collection is made easier by way of virtual assistants. Customer experience data collected by traditional support calls or chats typically requires analysts to scrub through countless hours of phone calls with information collected and recorded by a live customer support agent. With virtual assistants, customer queries and associated metadata can be instantly filed away and categorized for analysis without the need for a customer support agent to take perfect notes. As for a personalized user experience, AI assistants adapt to the needs of the user. They provide the client with a high level of personalization. For example, digital assistants can remember not only the user's name, but also their preferences. This helps to increase user engagement, as well as improve customer satisfaction and loyalty.
Definitely. What are the different types of AI virtual assistants?
Good question. There are several different types: chatbots, voice assistants, AI avatars, and domain-specific virtual assistants.
Can we talk a bit about chatbots first?
Chatbots have been a mainstay of the e-commerce sector since their inception. However, modern implementations of chatbots are powered by artificial intelligence. This gives them the ability to think through customer queries rather than push the customer through a chain of static events.
What about voice assistants?
Voice assistants use automatic speech recognition and natural language processing to give vocal responses to queries. This is what Siri and Google Assistant do.
How about AI avatars?
AI avatars are 3D models designed to look like humans. They are used for entertainment applications or to give a human touch to virtual customer support interactions. Cutting-edge technology from companies like NVIDIA are capable of producing nearly true-to-life human avatars in real time.
What about domain-specific virtual assistants?
These are highly specialized implementations of AI virtual assistants designed for very specific industries. They may be optimized for high performance in travel, finance, engineering, cybersecurity, and other demanding sectors. Specialized virtual assistant technologies also exist for specific tasks. For example, avatar-to-person (ATP) technology, based on artificial intelligence and 3D modeling technology, allows people with disabilities to perform tasks such as virtual face reconstruction and voice generation simulation to communicate online freely.
So let's say I wanted to create my own virtual assistant like Siri. How would I go about making it?
Your first and possibly least difficult option actually would be to integrate Siri into your application directly. Siri, Cortana, and Google Assistant are 3 well-known examples of AI assistants that many developers integrate into their applications. In 2016, Apple announced Siri SDK, a development kit that allowed programmers to integrate functions of their own apps as tasks that Siri could perform. Siri SDK uses intents as labels for user intentions and associates intents with custom classes and properties. If your company doesn't want to rely on existing AI assistant options, you'd need an expert team of AI engineers to build your own solution.
So what are the key AI technologies behind intelligent virtual assistants?
One of the most fundamental elements of AI virtual assistants is the use of speech-to-text and text-to-speech technologies. Speech-to-text allows apps to convert human speech into digital signals. This works by analyzing the vibrations created when the user speaks. Using an analog-to-digital converter, the software extracts the sound and segments it. It then can match the sound to existing phonemes. Phonemes are the smallest unit of a language. This makes it possible to distinguish the sounds of different words. Based on complex mathematical models, the system compares these phonemes with individual words and phrases and creates a text version of what you said. This way, it's possible to analyze commands given by a user or implement their speech into software for practical purposes.
What about text-to-speech?
Text-to-speech does the opposite. This technology translates text into voice output. Text-to-speech is a computer simulation of human speech from text using machine learning. The system must go through 3 steps to convert text to voice. First, the system needs to convert text to words, then perform a phonetic transcription, and then convert that transcription to speech. Speech-to-text and text-to-speech are used in virtual assistant technology to ensure smooth and efficient communication between users and applications. To turn a basic voice assistant with static commands into a proper AI assistant, you need to give the program the ability to interpret user requests with intelligent tagging and heuristics.
I've heard that computer vision is used a lot in this space. How do AI virtual assistants use this technology?
Computer vision is an AI technology that extracts meaningful information from visual inputs, like digital images or videos. This is an integral part of creating visual virtual assistants. These assistants can respond with creator-generated videos, not just sounds. This greatly enhances the user experience. Computer vision allows the system to recognize body language, which is a significant part of communication. Visual virtual assistants powered by this technology uses a camera that stores data and utilizes real-time face detection to detect when someone is looking at the screen. This sends a signal to the rest of the system, which converts the user's speech to text. Computer vision can also greatly increase the accuracy of speech recognition by comparing what the user has said verbally to the movement of the user's face and mouth.
Speaking of voice assistants, another example that I can think of is noise control. Can you tell us a bit more about that?
Yep, sure. Noise control is another critical feature for voice assistant accuracy. While many smartphones include software-based noise control and suppression features, You can't count on this being the case for all of your customers. To compensate for a lack of onboard noise suppression software, top-shelf Bluetooth headsets also include hardware noise suppression. But once again, there are no guarantees that your AI assistant is going to be able to detect what your customers are saying on a busy train or in your car. By integrating in-house noise control packages, you minimize the risk of misunderstanding voice queries.
If I have two different suppression features on at the same time during my Zoom calls, my colleagues sometimes complain that it's hard to hear me. From my own personal experience, it's also wise to make sure that noise suppression technologies don't overlap.
That seems like wise advice. Another technology that I can think of related to this is speech compression. Your AI assistant will need to store voice information, at least temporarily, for processing. Unless you want to fill up the customer's hard drive locally with voice data, speech compression is critical. But developers ride a fine line with compression. It's possible to compress an audio file so much that substantial amounts of fidelity are lost. This makes it difficult or even impossible to recover what was said when it was first recorded. Compression technology is rapidly improving. However, when developing your voice assistant program, audio codecs and compression solutions merit a thorough investigation.
What about natural language processing? How does that play a role here?
Once you have the voice data, the AI assistant needs to process and interpret the data with natural language processing. After that, it can execute requested commands. Natural language processing simplifies the speech recognition process. While many AI kits are pre-trained on countless hours of voice samples, you'll still need enough data from consumers to adjust for precision for your use case. If your AI assistant is going to respond verbally, you'll need speech synthesis, such as Google Cloud's top-of-the-line solutions. This produces realistic and clear voices. However, speech processing is not enough to derive a person's actual intent and maintain a normal conversation. The request still needs to be interpreted correctly based on context.
That's called natural language understanding, right?
Yep, that's right. Natural language understanding is a different approach to natural language processing and is considered by most computer and data scientists to be a subtopic of natural language processing. While NLP methods parse, tokenize, and standardize natural language into a standardized structure for command processing, NLU interprets the natural language without standardizing it and derives meaning from queries by identifying the context. More briefly, natural language processing takes grammar and structure and compensates for the user's errors, while natural language understanding examines the actual intent behind the query.
How does the AI assistant respond to the user? How is that done?
Natural language generation produces natural language output. Thanks to this technology, users receive human-like responses from virtual assistants and chatbots. Models and techniques used for natural language generation can be different and depend on the goals of the project and development approaches. One of the simplest approaches is a template system that can be used for text that have a predefined structure and require only a small amount of data to be filled in. This approach allows for gaps to be automatically filled in with data retrieved from a row in a spreadsheet, a record in a database table, and so on. Another approach is dynamic natural language generation. This does not require the developer to write code for each edge case and enables the system to react on its own. This is a more advanced type of natural language generation that relies on machine learning algorithms.
That's pretty impressive.
Definitely. Another technology used in this space is deep learning. Chatbots that utilized text-based responses are only substantially less complicated than voice assistants. Because you don't have to then convert speech into text for interpretation, you remove a lot of tooling from the equation when constructing a chatbot. Next-gen text generation technologies like GPT-3 can produce not only responses to basic queries, but entire new stories from a seed. Virtual assistants and chatbots powered by deep learning algorithms learn from collected data and human-to-human dialogue. Chatbots then utilize deep learning to examine existing interactions between customers and support staff. Then, paired messages and responses can be created that compensate for the user's typos and grammatical errors.
Another technology that I've read a lot about in the news related to virtual assistant software is augmented reality. Can we talk a bit more about how that's used in the real world?
Well, augmented reality allows you to overlay 3D objects in the real world for an immersive experience. This doesn't inherently have anything to do with virtual assistant technology, but businesses are using this as a medium to support AR-based mobile chatbots and AR avatars. For example, Arcade created a mobile AR avatar chatbot called Miss Perkins for the Ragged School Museum of East London. This assistant serves as a guide for museum visitors and quizzes them to create an interactive user experience.
That's pretty interesting.
Just wait. Another example of an intelligent AR chatbot was developed for the Vienna Museum of Technology. The creators used mobile AR as the medium. The functionality of the chatbot includes conducting tours and answering user questions about specific display items in the text, images, videos, and audio formats.
This sounds to me like it has a lot to do with the metaverse.
You're totally right. The rise of the metaverse and VR technology shows us that 3D AI avatars are useful in a variety of different applications. Combined with artificial intelligence, AR virtual assistants become more functional, bypassing the limitations of existing AR tools. For example, deep learning allows virtual assistants to capture user behavior in real time to derive neural networks that automatically train and improve virtual assistant performance.
We've talked about how users can interact with this technology. However, could an AI virtual assistant create something of its own?
Yes, this is definitely possible with generative adversarial networks. This allows for the creation of new instances of synthetic data due to the algorithmic architectures that are used in neural networks. Generative adversarial networks consist of real image samples and generators fed into discriminators. This allows for the generation of a realistic 3D face for AI avatars and 3D assistants, as well as other applications. The technology has been utilized in many video games and other products to create true-to-life human figures. Generative adversarial networks can also be used to turn still images into full-depth 3D images. Perhaps the most advanced integration of AI avatars so far is NVIDIA Omniverse avatar project Maxine, which creates a photorealistic real-time animation of a human face speaking a text-to-speech sample.
That's amazing. One thing I'm particularly interested in is how artificial intelligence software can interpret human emotion. There's a lot of valuable context from human emotion that's lost when you only take spoken words at face value. For instance, machines can't understand sarcasm or irritability in a person's voice, which can lead to misunderstandings.
Well, this is a technology that's being worked on. Emotional intelligence is important for AI avatars or 3D virtual assistants. This technology uses AI to track the user's nonverbal behavior in real time when communicating, so that the system can react accordingly. This can help make virtual assistants more responsive, thanks to emotion AI that monitors human facial expressions, body language, and inflection. Emotional intelligence is powered by computer vision in machine learning algorithms. Facial recognition technology analyzes facial expressions using a standard webcam or smartphone camera. Computer vision algorithms identify the main points of a person's face and track their movement to interpret emotions. Next, the system determines the person's feelings based on a combination of facial expressions by comparing the collected data with a library of template images. Solutions such as Effectiva or Kairos can measure emotional metrics like joy, sadness, anger, contempt, disgust, fear, and surprise. Interpreting emotion from speech is also important. This kind of software analyzes not only what the user says, but how it is said. To do this, the system extracts paralinguistic features that help to identify changes in tone, volume, and tempo. This makes it easier to interpret these features as human emotions.
What do you think are the main challenges for virtual AI assistant technology moving into the future?
Well, the adoption of a virtual assistant technology definitely has some challenges. One major obstacle to the future of AI assistant technology are laws concerning data storage and usage. Unchecked use of customer data as training data for AI implementations could easily be challenged by changing data security laws in countries across the world. Controversial data handling policies by companies like Meta, formerly Facebook, have stoked fears of corporate overreach and privacy concerns after the events of high-profile whistleblower scandals. Therefore, when developing an AI assistant app, it's important to take into account the requirements of privacy and data protection. A great box to check is compliance with GDPR in the European Union. Keeping your application compliant is important for making it accessible for your users.
I agree with that. Businesses won't want to use software that isn't compliant.
The future of AI assistant technology looks bright. Advances in technology are also driving the development of smarter virtual assistants. As natural language processing continues to evolve, virtual assistants will be able to perform more complex tasks. In particular, virtual assistants will be able to make proactive suggestions that make self-learning algorithms even more helpful for users.
There's a lot of focus on the metaverse lately. How do you think AI virtual assistant technology will evolve in relation to that?
The development of the metaverse is very closely linked with AI virtual assistants. Intelligent avatars are the best way to provide a user's identity in a 3D universe. Artificial intelligence is what will allow us to achieve greater realism with 3D avatars. By studying physical movements, AI models can learn and more accurately predict the positioning of limbs. For example, the position of shoulders and elbows can be more accurately portrayed based on where your headset and controllers are.
That's fascinating.
I agree. There are a lot of different technologies and applications of artificial intelligence-powered virtual assistants. However, this is all just the beginning of what they're capable of.
Definitely. If you're looking to create an AI virtual assistant solution for your business, it's important to consider the existing technologies that are powering virtual assistants around the world. As this technology continues to grow and evolve, those who understand its potential and limitations can build innovative solutions that can make their businesses more competitive and relevant in the market. Partnering with artificial intelligence and machine learning experts to produce solutions like these is a great way to get started. Our team has repeatedly ranked among the top software development companies, according to Clutch, Upwork, Good Firms, and other sites. We highly encourage you to check out our AI consulting services or contact us directly to discuss your next project by sending an email to contact@mobidev.biz.
That about wraps up today's episode. AI-powered virtual assistants are a fascinating technology that's growing each passing year. I'm really excited to see how the technology evolves in the future.
Me too. The more that technologies like this evolve, the more that I feel like science fiction is becoming reality. Thank you so much for joining us today. If you enjoyed this podcast, please subscribe and share this episode with a friend or colleague. Please join us next time to learn more about the innovative technological solutions that are driving our world forward.
Take care, everyone.